program and what each function does, and I'll try to make it quick as possible. So first things first, this is the main file, so this is where we're running the code. And I have include statements. This is how we linked our program. So to start off, I'm going to show you board. So this is what the board looks like. It's just an array of ASCIIs, and it contains all the valid moves. And as we go through all the functions, it'll update these values in the ASCII in each of the rows. So from main, the first thing we do is we load these value 1 and 1 into S3 and S4. So this basically represents the previous turn. So since this is the first run of the function, it's going to start with 1 and 1. So the user can choose a value. So let me just run it and I'll go through it. So the user has to enter a valid turn. So first it loads S3 and S4, the previous values of 1 and 1, and we display board. And then here we're just printing the message of, your move is X, their move is Y, and then we're prompting the user to enter values. So when I call user move, I'll just enter a valid move really fast. So 1 and 9 is a valid turn. So within user move is going to call, or first it's going to take the input and it's going to check if that input is in bounds. So if it's between 1 through 9, then we call validate move. So this is the file. It's going to call validate move, and then within validate move, we're going to do some checking. So S3 and S4 represent the previous value. So 1 and 1 was the previous turn, and this will change based on the turn that previously happened. So first we check at the very first turn, the previous value is 1 and 1, and the user entered 1 and 9. So to be a valid turn, one of the numbers has to be the same as the other number. So we can only change one of the numbers. So basically it's just ensuring that one of the numbers is the same as the previous turn. So we have 1 and 9 and 1 and 1. 1 is the same number in the previous value move. So that's fine. And then after that, validate move also checks through and iterates through this array to check if 9 is still present, the multiplication value of 1 and 9. So it checks if 9 is present. If it's present, then it's basically going to return back to user move with the value in the register that indicates that it was a valid move, and then we should continue with the program. So here, after user move is finished and it runs this code here, this is just an indicator to update board that the value we want to replace. So 9, we want to replace 9 with X's. So if it's 0, it's X when we load to update board, and when it's 1, like here, for example, after a computer ran their move, it's going to be O, because 1 is the indicator for O in that function. So after display board, after all these functions are done, after we display the board, after the user goes, so here 9 is replaced and the computer has to go. So but before we get to that, first after we display this board, it's going to check if the user has won. And since we don't have 4 in a row yet, it's going to keep going with the program. So when computer move goes, it's just going to take the value in the previous register, so 1 and 2. So S3 and S4 will be loaded with the 1 and 2 after user move is finished. And user move just basically takes the value in S3, and it's going to multiply numbers 1 through 9. So it's going to go through, 1 times 1, 1 times 2, 1 times 3, and so on until it reaches a valid move. So the first move it found was 1 and 1. It's going to take 1 and 1. It's going to multiply them, and it's going to run validate move. If the value is still present in the array at this point, then we're good, and we can replace it with an O. So that's going to keep going, and it's going to check if there's a winner if O was there 4 times in a row. But since it's not, we're going to continue the game. So that's basically what all these functions do here. And this will exit the program, but yeah, let's just exit the program. So I'm going to play to win, so I'll show you that the code does work, and then once we get a winner, it'll probably show. So I'm going to try to do this as fast as I can. So we played 3, computer played 6, so we have 2 right here. So we should probably try to win with 16 or 18. We'll try to go 4 in a row and get 18. So computer played 12, and we want 28 to win, and we can't do it on this turn. So let's just try to get a 4 in the mix. 1 and 4, yeah, there we go. So now I can play 7 and 4. We can get 28, and as you can see, the program is done because we have 4 X's in a row vertically, and it's going to print our winner board, which indicates that you won. And if you lost, it would have showed the loser text. So this is what loser looks like. It'll just print loser and L's and O's and with the letters. So yeah, that's our program, and thank you.